Hello, Algebra 2. This is lesson 5.4, complex numbers. And so complex numbers is this whole other number system. Really, this is the full number system, the complex number system. And if this is our number system, we have the complex numbers is the whole thing. And inside the complex numbers, we have the reals. The real numbers, which is everything that we normally work in. And the real number system is the numbers like -2 and 1/2 and 5/8 and pi and radical 2. And these are all real numbers, and negative radical 3. But we also have this other whole number set called the complex numbers or the imaginary numbers. So these are the imaginary numbers, and together the real numbers and the imaginary numbers form the complex number system. So the imaginary numbers are I for imaginary. That's kind of nice. That's a 1I. And we can combine real things with imaginary things. So 3 plus 2I is a complex number. And pi plus 3I is a complex number, or radical 2 minus 5I is a complex number. And it has a real part and an imaginary part. So we're talking today about imaginary numbers. So for a moment, we're going to go back. We were factoring and solving in the previous unit. And so this is x squared minus 25, and factor means double bubble. So I'm going to double bubble this. X times x is x squared. And last times last has to give me the last thing. What times what gives me negative 25? Well, positive 5 times negative 5 gives me negative 25. And since it's set equal to 0, I can set each bubble equal to 0. And then isolate x. So I'm just going to move the 5 to the opposite side by doing the opposite. So x equals positive 5. So here we get two solutions for x. X equals 5 and x equals negative 5. It's really important that you know that we get two answers because this is x squared. It's x times x. There are two answers for x. Okay, so then the question is, well, what happens if I have x squared plus 25, and I want to be able to solve that? The problem is I cannot factor it because x times x is x squared, and positive 5 times positive 5 is positive 25. But this actually creates a different polynomial if I were to multiply out. So this is sort of a false statement. It doesn't actually factor. Because if you were to check this, we'd get x squared plus 5x plus 5x plus 25. So we actually get something different. And so this doesn't actually factor. So whoops, that doesn't work. But we have to be able to solve stuff like this. And so in order to do that, we had to create a special character. And that special character is I. And so what we have is we have the square root of a negative 1. All right. So this is anytime we see a negative under the radical, it gets to come out as I for imaginary. And this is really important. Before, I couldn't take the square root of a negative number, but now I can. So using imaginary. So that's what we're working on today. Example 1, rewrite the expression as a complex number. Simplify any radicals. Rewrite the expression as a complex number. And a complex number just has i's in it. And so we want to remember that the square root of -1 is I. So they are equal to each other. They can be replaced. So I can think about this as radical -16. Again, using that product of radicals, this breaks apart into the square root of -1 times the square root of 16, which is kind of nice because what is the square root of -1? I. What is the square root of 16? 4. So we get I times 4 or 4I, which is how we would normally write that. Okay. Here we have another radical. We're going to, again, split that apart. So I'm going to split that apart into negative radical 1 times radical 25. And again, so what is the square root of -1? Imaginary. What is the square root of 25? 5. And hey, don't forget about this negative hanging out in front. And I'm just going to, it looks kind of weird. So we're going to say -5i. So there is our complex number, -5i. So this is a negative times 5 times I. You can write them in any way you want. But this is probably the standard way. All right, let's look at this one. We have the negative there. So that's the square root of -1 times the square root of 15. 15 is 5 times 3. I don't have a perfect square in there, so I can't simplify it. But I can simplify the square root of -1, which is I. And radical 15 is just going to stay under the radical. So we get I radical 15. Here we have another radical. So I'm going to break that apart into that negative, which I can think about as -1. So the square root of -1. And then the square root of 18. And 18 breaks apart into 9 times 2. So radical 9 times radical 2. So breaking all of that apart, I know that the square root of -1 is an I. The square root of 9 is 3. And I can't do anything with the 2. It's prime. And hey, don't forget about your negative. So I think to put this all together, -3i radical 2 is how I would write that in sort of a standard sort of way. Okay, so that is simplifying complex numbers, just sort of pulling things apart, looking for perfect squares, looking for i's, and going from there. All right, let's try some more. All right, so here again, I have something under a radical. I need to simplify that. So that's going to be the square root of -1 times the square root of 6. Again, 6 is 2 times 3. Prime numbers can't be simplified, but I can simplify this. So that becomes an I with a radical 6. And I'm going to bring down my negative and bring down my 3. And hey, guess what? That's the answer. 3 minus I radical 6. And that is a fantastic answer. Again, here's my radical. I'm going to try and simplify that first. So that's going to be negative radical 1 times the radical 49. Square root of -1 is I. Square root of 49 is 7. I'm going to bring down the rest of this stuff here. So we have 6, we have the minus sign, and then 7 times I, or 7i. And hey, this is a great answer. So this is the real part, and this is the imaginary part. Imaginary because it's got the I attached. And this is how we usually like to write complex numbers in A plus BI form. Okay, so that is normally how we write it, where A represents a real number and I represents an imaginary portion. All right, now we've got a couple of radicals to simplify here. So radical 45 with a negative. So I have that radical of -1. And then 45 breaks apart into 9 times 5. And then I also have this radical 80. So let's think about that. I'm going to do this so we can see that we're all right. So 80. I got radical negative 1s again. 80 is 10 times 8. It's just thinking through numbers. And again, I'm trying to find the largest perfect square. Oh, you know what? Is it 16 times 5? I think so. Let me double check. Let's see, 16 times 5. Again, sometimes the numbers that we just don't multiply very often. Yep, 16 times 5 is 80. 80 is a good one to pay attention to. So radical 16 times radical 5. All right, let's clean this up. So we have the 4 and the plus sign. The square root of 9 is 3. The square root of negative 1 is I. And the radical 5 has to stay. Then we have a big subtraction sign. And over here, the square root of 16 is 4. And the square root of negative 1 is I with a radical 5. And now look, we've got some like radicals. 3i radical 5 minus 4i radical 5 is negative 1i radical 5. There's a 4 still hanging out in front. So this is 4 minus I radical 5. You can write the 1 or you don't need the 1. It means the same thing. All right, a little bit here. And again, it is super important that you simplify your radicals first. You must do that. Like these don't just cancel each other out. So this square root of 49, that's just 7. And then here we have a big subtraction sign, and now we have the square root of negative 1 times the square root of 49. So the square root of 49 is 7, and the square root of negative 1 is I. So this is 7 minus 7i, and that is a fantastic number. A fantastic complex number, ladies and gentlemen. Kind of nice. So we are simplifying with I today. So the very important thing to do today is to remember that anytime you have a negative under a radical, you get to take an I out. An I pops out of the radical. Really interesting. Okay. All right, ladies and gentlemen, have fun with I.1.